All right, hello everyone, and thank you for joining us for today's webinar brought to you by Codefresh Live. Today we are presenting Detect, Debug, Deploy with Codefresh and Lightstep. Our presenters are Austin Parker, Principal Developer Advocate for Lightstep, and Guy Sultan, Solution Architect for Codefresh. Today they're going to show you how to ensure that every new deployment is more prominent, more stable, and more robust than your last. Lastly, please remember to reference codefresh.io/events for our upcoming webinars, as we have fresh and informative webinars for you several times a month. So that's it for the housekeeping items. And with that, I will hand it over to Guy to kick off the presentation.
Thank you very much, Taryn. Welcome, everybody. Thank you for joining. This is going to be a very cool webinar. I think we're going to see how you can better understand if your deployments are successful, how to measure what successful means, and then how to easily roll back your containerized application using Codefresh and Lightstep. So if you can just skip the slide there, Austin. My name is Guy. I'm a solutions architect working for Codefresh, been with the company for about 1.5 years now. So yeah, as part of my job, I'm also working on technical marketing content, webinar, blogs, stuff like that. You have my emails down there, so you can feel free to send me any questions about CI/CD, containers, Kubernetes, deployment, stuff like that. Yeah, that's a bit about me.
Yeah, and I'm Austin Parker. I'm Principal Developer Advocate at Lightstep. I've been with the company for about 2 years now. And my role is really to kind of connect with our developer community and the wider observability community, help sort of drive forward best practices around how to instrument your applications for observability. And a really critical part of that is how CI/CD plays into the observability sort of cycle. So I'm really excited to show you all some cool stuff here today. And I think first we're gonna go through our agenda. So we'll talk a little bit about Codefresh and Lightstep. Guy's gonna tell you a lot about that. I'll tell you about Lightstep. I'll talk about, what is observability, how does it relate to CI/CD, and then we've got a really neat demo to show you. And finally, we'll kind of wrap it up. So if you want to follow along, you want to see the code examples we're going to be working with, be sure to check out the link there, that GitHub link at the bottom, and you'll be able to kind of replicate this on your own after the webinar if you'd like. So first, let's start the Guy and talk a little bit about Codefresh.
Yep, thank you, Austin. So Codefresh, for those who are not familiar with it, is the first CI/CD platform, container native CI/CD platform built for Kubernetes and microservices. So when I say container native, what we mean is, if you look at this diagram on the right, showing a classic CI/CD pipeline, starting with maybe a Git trigger, like a commit or a pull request, then going through a multi-stage build, then maybe packaging a Helm chart, running some tests like integration, performance, security tests, then pushing your artifacts like your Helm charts or Docker images into your Docker registry and Helm repository, and then finally deploying your application to Kubernetes. With Codefresh, each of these steps runs inside a Docker container. So this provides obviously isolation, but also ease of use and management and maintenance of your pipelines. It's a SaaS platform, so you don't really have to manage your slaves, right? The build nodes themselves. Every step just brings its own Docker image with the tools that it needs and runs the actual action. It's also a pretty intuitive platform. So you'll see, for those of you who are familiar with more traditional CI tools, I think you'll like the UI and UX of the platform. Yeah, we also have some enterprise readiness features like SSO and stuff like that. And finally, flexible delivery that refers to the different installation options. So as I mentioned, it's a SaaS platform. But you can, we also have a full on-premise offering, as well as a hybrid offering where you can still work with your SaaS account, but install an agent on your own Kubernetes cluster and then run your pipelines behind the firewall. So yeah, it's not really the focus of today's webinar, but yeah, you definitely see Codefresh in the next few minutes.
Yeah, and so Lightstep is a observability platform that's kind of built for modern distributed systems, like applications that you might find running on Kubernetes deployed through tools like Helm. Some of the things that really stand out about Lightstep is we offer the ability to analyze 100% of the requests that come into your application at any scale. We automatically can detect regressions in deployments and in just kind of normal behavior. We offer aggregate trace analysis, real-time root cause analysis, alerting features, and the setup is very easy. Lightstep is a SaaS platform that kind of runs in a hybrid model where you're able to run parts of the infrastructure in your data center and your VPC. We also offer fully managed services. And this is all built on open source technology, so there's no vendor lock-in. If you instrument for Lightstep, you've instrumented for every observability tool. Now, a good place to start is kind of explaining, what is observability? I think a lot of people hear CI/CD and they kind of know what we're talking about, but maybe observability is a new term to you. So fundamentally, observability is a process and a practice and tools that help you understand your system. A lot of times I get a question that I'm going to head off at the pass here. It's like, what's the difference between this and like APM or this and system monitoring, right? So fundamentally, observability is about giving you the information you need to answer sort of unknown unknowns, right? There's a lot of questions that you will, I think we've all been there, right? Before I got into this, I worked as a DevOps engineer. And the biggest question I had to deal with every day is like, why did things break? Why did things not work right? Traditional monitoring doesn't necessarily give you all the tools that you need. It doesn't give you all the data you need. There's this quote I like that was published in the News Stack, which is that monitoring is really about knowing up front kind of what are the things that we care about and then working really hard to keep everything in that sort of narrow channel of normalcy. Observability is about making sure you have all the data to ask these questions in real time and get answers to them in real time, so that when you do have an incident or you are trying to improve performance, that you will be able to ask the interesting questions you need to in order to improve your overall performance, latency, errors, whatever it is that you're trying to target. As it relates to CI/CD, the great thing about CI/CD is that I'm more agile, right? I have higher velocity. I can deploy more quickly. I can theoretically ensure that I'm not breaking the world every time I push new code. But that velocity comes at the trade-off of how do I actually know that the changes I'm making, the PRs that I'm merging are actually kind of tracking towards the goals I have. Observability is a critical part of this. If you just have CI/CD and you just have the ability to release very rapidly, but you don't have observability, then it becomes much harder. Everyone's kind of building on sand at that point versus on a stable foundation. So you need observability tooling and you need observability practices to help you measure your system and understand it. The first step to kind of get observability is you need to instrument your code in some way. Now, in the demo we're going to do here, we've already done this step, but I want to touch on it a little bit, and we'll go a little deeper into this later when we look at the actual program we're running. But generally, I recommend that people focus on using open source tools to do this instrumentation. So for our example today, we're using OpenTelemetry, which is, it's in beta now. It's a open source API and SDK for instrumenting your code for observability. Integrating it is pretty straightforward. We're going to use a Go application today. All you really need to do is import some dependencies and then kind of wrap your existing HTTP routes or whatever libraries you're using in instrumentation code. This is available for a variety of languages, though, not just Go. It's available for Java, JavaScript, Python, C#, Ruby, a couple others. You can find a full list at opentelemetry.io along with more documentation and resources on how to get started. Thank you, Robert. I'm a big fan of the microphone. So let's talk about kind of the preconditions, because we're going to switch real quick here into our actual demo and kind of go through some stuff. So I want to sort of set the level, do a level set on what we actually have. So before this, we went and set up Codefresh with a Kubernetes cluster attached to it. I'm using GKE, Google Kubernetes Engine. We have a sample application that has a Helm chart that we will use to actually deploy our container once it's built. And let's start out by assuming that this is some service that's running and we want to release a new version of that application. So let's jump into Codefresh, and I think Guy and I are kind of going to jump in and out here as we get to our specific pieces of expertise.
Yeah.
So here's Codefresh.
Yeah, this is Codefresh for those who are not familiar with it. So as I mentioned, a SaaS platform. As Austin mentioned, this Go application was already deployed to our Kubernetes cluster. So we integrate our GKE cluster into this Codefresh account. You can just show this last build that was performed. So you see this CI/CD pipeline that we already ran. It has 3 simple steps, right? We cloned the GitHub repo that contains our Go application, then built the Docker image for this application, and finally deployed it using our Helm chart. So to build such a pipeline in Codefresh, you use you can just click on the pipeline itself. There, Austin. And we'll talk about the actual execution later on. So you see it's using declarative YAML, we're currently storing this YAML file in the same GitHub repo where our application is hosted. So this way we can also manage the pipeline YAML itself under version control. And to build the actual pipeline, it's pretty easy. You see you have all these built-in steps on the right-hand side. So each of these steps runs as a Docker image. So you see a lot of steps there, like deploying a Lambda function, running security scans, deploying them to different destinations, like not only Kubernetes, but also ECS and Heroku and stuff like that. And you can click, and maybe Austin just click on like the Helm step, for example, or whatever. So you can just click on each of these steps. You see they're all like declarative and designed as self-contained function, in the sense that you don't have to start building your bash scripts to handle deployments or whatever. You can just set the type of the step as, for example, git clone or build, and then just pass the a few arguments to build your image, deploy your application, etc.
Yeah. So what if I'm going to go and switch over real quick to Visual Studio Code here. And this is the actual repository that this is all in. Like I said, you can see this on GitHub. For the purposes of kind of demonstration, where you have a build argument that, wow, I have to click on the right thing. So this is our Docker file, and this Docker file takes a argument from the Docker build command, and we'll switch between 2 different directories, one with a slow version of the application, one with a fast version of the application. So I'm going to edit this file, and I'm going to say we're going to switch between fast and slow.
Yeah, just a small note there. As you can see in the build step, we're going to tag the Docker image with the commit SHA that comes from GitHub. So you see, you can just use these system variables, the one that starts with the CF_, then short revision. This way, it would be easier for us to understand and trace back our images, even after that they're deployed to our cluster, back to the actual code change. And
yep. So let me switch back over now because I went ahead and pushed that to my GitHub repo. So let's go back over to Codefresh.
Yeah, we also pre-configured a Git trigger. So once Austin committed and pushed his code, this automatically started a new build.
Right, which you see right here, where this pipeline is running. I'm able to go in, view sort of the output of that build in Codefresh. There's other interesting things you can do here. You can kind of look at the metrics of your build container, which is really cool. See how much memory is being used. You can look at the
Yeah, you can
YAML
show
itself.
the log of the build step that was just completed. So it has built-in caching, both Docker build caching as well as distributed layer caching. So we can actually look at the layers and you can see that it says using cache to build some of them. So the image, once it's built using this build step, is automatically pushed to our Docker registry that we integrated into the cluster. To the account, and then it just uses it for caching.
Yeah, and then once it's done that, we can go down here and we can see that it has deployed the Helm chart that is included there. And success, success, success. Everything looks good. So while we're talking about that, let's look at a couple of other things. One thing I think is really neat is, like as Guy said, we're building a Docker image and we're pushing this to the Docker a Docker registry. Now I have my Docker Hub account configured here, but you could use I believe pretty much any Docker registry.
Yeah,
Certainly
any
the
Docker
container
registry,
registry,
GCR, Artifactory.
yeah. And so we can also go in and look at sort of details about that image. I can see, there's a lot of annotations that Codefresh allows you to sort of push in here. Things like, you can attach this to a Jira ticket. You can say, what's the test coverage of this image? Did it pass performance or latency checks? Some of this is just kind of data we put in here, but in the real world, this would be information from your system, from sort of your build systems, your test systems. I can also go in to sort of our...
Before that, maybe, Austin, if you can just go back quickly to the image view.
Images?
Yeah, images view, and click back on that image. Another cool thing that you can see here at the code section is that you can easily trace back from this image back to the, if you can even click on the commitcha there, and then it just takes you back to GitHub and you see the actual change that Austin just made a few minutes ago, right? So
yeah. Really cool. I can also see that Helm release like we were talking about. So if I go into Helm, this is my chart that I deployed, and I'm able to kind of look at the endpoint for this application. I'm able to also see the history. So we've obviously been deploying this quite a few times. And I can look at, the actual values of the Helm chart, so I can see, what's the template look like? What's the deployment template look like? Really everything you would need to be able to understand what is actually going on in Helm. You can also view the manifest, so you can view the computed values, which we will not show because there's an API key in it. But this information is all super valuable for you when you're trying, if you're building and releasing and you want to kind of trace back like what exactly happened over the course of a deployment. So while we have a minute, is that because it's a rolling release, so it takes a few minutes for it to kind of go out and deploy new versions of that containers. Let's explore the code a little bit. So like I said, we have effectively the same application here, just two different versions of it. We'll start with what I've called the fast version. So this is just a trivial HTTP server written in Go. And if we start from the top, you can have some of your standard library stuff, format, log, math. We use that later, net HTTP. And then we have a bunch of imports for OpenTelemetry. Like I said at the jump, OpenTelemetry is an API and SDK that helps you implement observability or instrument your applications for observability. That works in several different ways. You can instrument your code manually. You can use varying forms of automatic instrumentation. So for Go, this takes the form of a wrapper around a library. Quick question: does Lightstep only use OpenTelemetry, or does it also use Open Tracing? We support Open Tracing, Open Census, and OpenTelemetry, as well as Jaeger or Zipkin span data if you're using those. OpenTelemetry is the newest thing, so it's the thing I demo. I also am a maintainer on OpenTelemetry, so biased. So in our application code here, there's a couple of tracing related things we're doing. So we're setting up a exporter for our data from OpenTelemetry to Lightstep, which is what this stuff here is doing in our init tracer. We create a new open tracing provider, add some configuration to it. We want to always sample, so we want 100% of the data to go to Lightstep, and then we set up a syncer or an exporter that sends the data that this generates to Lightstep. Finally, we set our global trace provider to be the new trace provider we created. Down here in main, we are initializing our tracer. We are creating a random seed that we use later. And we have a handler for the, just index for the root route. And the only difference really between this and maybe what you would normally see in a Go net HTTP server is instead of just passing handler func to mux.handle, we've wrapped that in this OT HTTP library. As you'll see later, this adds this creates a span, this creates a trace off of each request that comes in that is then sent to Lightstep. In our actual handler code, we don't do a ton. I'm setting some attributes on the trace that we will use in Lightstep later to show us the version of the service. And also, I'm putting the build ID of the Codefresh build in here, which we'll see what we use that for later. But you can really add a lot of different attributes to your traces, and that's useful not just in Lightstep, but really in any sort of trace analyzer tool. It helps you filter and sort and aggregate your span data and help you discover interesting things. In this case, it will help us see what changed from one version of a deployment to another. Finally, we sleep for a random amount of time because that makes a more pretty histogram, and we return a line that says, hey, I'm a Go application running inside Docker. The slow version of this, which is what we just deployed, adds a wrinkle to our index handler. So we do some basic modulo math to kind of provide a distribution of slow requests. We pretend that this is an error case. So we set an attribute on the trace of error equal to true. And then instead of sleeping for however long, 100 milliseconds, we multiply that by 3 and sleep that long. Now, in the real world, problems are not quite so easy to find, right? Or they don't present quite so easily. But it is pretty free. I do find a lot of times that you will deploy something and suddenly error rate starts to spike, latency starts to increase, and you don't really know why. You need to be, and maybe you don't have this a tool sophisticated enough to actually tell you exactly why that's happening. So this is where Lightstep comes in, right? If I go over and I look at Lightstep and I look at my service directory here, so this is the Helm application I just deployed from Codefresh. And we can see that Lightstep is already starting to detect sort of some stuff going on. This marker here is what we call deployment marker. Now, one thing that's interesting, if you've used other sort of observability tools or monitoring tools, you might know, deployment markers might not be a new concept, but a lot of times those markers come from an integration between the CI/CD system and your monitoring tool, right? You have to, when you do a build, you have to, post something that says, hey, I just deployed a new version of this. With Lightstep, we're actually automatically detecting that a new version was deployed based off of, if I go back to my web server, we're setting the service version tag, and then in my Helm chart, I'm passing in the get SHA of the container. When Lightstep sees that, we say, oh, that's a new version of this service, and we put this deployment marker on here. We're also able to do things like show you sort of the staged rollout. So in this case, since we're doing this Helm deployment where it's, I think we have like 3 replicas, so it's not just turning everything off and then back on again, it's replacing one container after another. And you can actually see this dotted line here where this is our new version, and the traffic is slowly cutting over from over the course of like a minute or so, but it's cutting over from the old version to the new version, and we're able to detect that and tell you, how much traffic is going to each version at any given time. If I wanted to explore this more, I can actually click on my deployment marker here, and I can analyze, my regression state and then my baseline. So this is going to be kind of what's going on right now, and then the baseline will be an hour before this. So I can see that 2 things have happened. One, that before there weren't any errors, and now there's significantly more errors. And 2, I can see that there's been a 10 millisecond increase in latency between these 2. I can also view on this histogram here where the blue is kind of my baseline. If I look at the, this performance trend, where the P95 is, there wasn't a ton of stuff up here before. The yellow bars show my current, what I'm currently looking at, and now I can see that there's significantly more, high latency transactions or requests taking place. If I wanted to dig into this more, like maybe I look at one of these specific spans with an error on it, I can see some of the data that I put in there before, build ID, version number, and I'm actually even able to, through something called workflow links in Lightstep, I can make an integrate. I can actually link this back to the build it happened in. So if I click this, I'm able to load up Codefresh and then go back to the exact build that I just showed you all a little while ago, where this occurred. And this is a great way to sort of keep track of what's happening in your application as you're building new versions. You can always go back and look at like, hey, exactly what changed here. I can jump to the commit that changed this. Pretty neat stuff. But let's assume for the purposes of discussion that I don't really want to have this version in the wild with, high P99 latency. I want to go back to how it was before. So we go back to Codefresh and we'll go into our Helm releases again. And I can go into history here, and this v37 is what's currently deployed. Let's say I just want to roll back to the last known good version. I click rollback, perform.
Yeah, so you can just do that with a click of a button. And by the way, what this will do is by default, it will just initialize the system rollback pipeline, as Helm has, built-in support for rolling back to previous versions of the same release. It would just roll back to revision 36, right? Yeah. But if you go back, Austin, to the releases, Helm releases dashboard again, the Helm releases, you click on the cogwheel there, you see you can even define your own rollback pipeline. So if you want to tweak it, you want to send some webhook after like you perform the rollback, or you want to do like your own customized rollback pipeline, then you can do that as well. And we support both Helm 3 and Helm 2. In this case, we're actually using Helm 3. But if you are still using Helm 2, then that is supported as well.
Yeah. So let's check on our rollback here. Looks like we have indeed rolled back to release 36. And now if I jump to Lightstep again, what we should see here momentarily is a change in these, both the latency and the error percentage graphs.
Exactly. So it should roll back to the previous image tag, and we should see this in here in Lightstep.
Yep, which I think is this 9F6. Yeah, so by changing the version up here, but and if you change, you can also change the resolution of this. Like right now, I've got it narrowed down to just the last hour. But if you were doing multiple releases, multiple releases a day or something, it'll show everything kind of in that window. So
yeah, so this is generally a good practice. You can even add, we also expose a system variable for the branch. So I like to add like the branch and then the commit SHA. And this way, you know exactly like which branch it initiated from and what is the actual commit. So I know that some people are using like for their Docker image tags, just use like V1, V2, etc. I find it a better way to just use the commit SHA. It's much easier to trace back to the changes in Git.
Yeah, I can say internally we use commit SHA as the tag for our images and for our releases. So now we can see I've got it still set on the slow version, but you can see over here on our operation rate that this is starting to change, right? Like before I was at 100% traffic, now I'm at 22% of traffic. So you can see how this is cutting over from the new version back to the old one. And you can also see on our latency graph here, as this cutover happens, the slow version is getting less traffic, and our latency distribution is changing as well. If I want to look at this in more detail, and let's say this was cool, right? Like I can go and I can do this kind of by hand, but maybe you wanted to do this automatically. So we also support things like that through what we call streams. Like any good, monitoring observability platform, we offer the ability to set up customizable alerts. So I'm going to zoom in to just say the last 15 minutes here. And here we can see kind of more detail about not only sort of more detail on a longer term, so I could go back 30 days or a custom time range, but you can see our latency distributions. Within this, I can actually hover over these. These are individual exemplar traces. So if I click on this, I will go into our trace view, where we will still see various tags and logs, workflow links, details about that span, or about that trace, I should say, sorry. And let's say I wanted to make a condition so that if this happened again, I would get an alert. Pretty straightforward. You go up here, create condition. I say, P99 latency high. I can customize my threshold and say, let's say that's over 500 milliseconds over the last 5 minutes. And then I would add an integration here to either PagerDuty, Slack, or we have custom webhook support. So if you wanted to do this with Codefresh, like you could set up a webhook back to the Codefresh API that when this happened, it would maybe even trigger an automated rollback through Helm, or it could alert you through any number of other ways, right? Another interesting sort of integration option here would be to maybe if you had like an automated canary process, right? Codefresh allows you to sort of put a hold on deployment, so you could have a pipeline that, rolled out to 25% or 20% or 2% or whatever your canary was, have a condition in Lightstep that would check to see if those canary builds were doing okay. And if they were, because this latency, this can be above or below, right? So you could say the latency has to be below 50 milliseconds or whatever your kind of agreed upon service level is. And then if that happened over 10 minutes for canary releases only, send something back to Codefresh that would continue the rollout to 100% of users. So that's, yeah, I guess the only other thing is, there's all of these analytical features are kind of available in all of our various different views in the product. So, you can use that high-level deployments, root cause analysis view. We also can just let you see everything that's going on. So one thing that is different from us and a lot of other things is our sample, we don't upfront sample your data. It's done in what's called the Lightstep satellite. So this view that I'm looking at here, this is 100% of the requests that have been flowing through the application. We keep them for about 15 minutes is the window we shoot for. And I'm able to not miss any outliers, right? So if this was right now, I can see here's the average latency for the slow version, here's the average latency for the fast version. That only happened in 793 traces before we changed it. But you can imagine that if this was something that 1% of traffic that was going to, it would be possibly very easy to miss those outliers in a different observability tool. With Lightstep, you don't miss any of that, fine-grained resolution, and you're able to more easily understand what's happening. And you can kind of subdivide this by any sort of dimension that you've applied through tags and attributes. So that's Lightstep and Codefresh, I think, in a nutshell. Did you have anything else we wanted to show in Codefresh, Guy?
No, I think, yeah, you can click quickly on the accounts settings. Yeah, this is where you can, this is what we did before the webinar. So yeah, you have the Kubernetes integration there. You can add and like integrate any Kubernetes provider if it's a GKE. I saw there was a question about OpenShift. This is also supported. EKS, AKS, whatever you use, as well as on-premise clusters using this custom provider option. If you go back to integrations, another thing that we added and we discussed this earlier is the Docker registry. We're just using Docker Hub, but you have built-in integration.
You can do other stuff,
Exactly. And it also comes with a built-in Helm repository, and you can also integrate your own external repository. So it's not mandatory to use a Helm repository. Like in this demo, we just had our Helm chart in our Git repo, and we just deployed it directly from there. But you can, of course, utilize this built-in Helm repository.
It's pretty, I will say, like, I hadn't used Codefresh before until I started going through this demo or setting up this demo with you all. I hadn't really used Codefresh, and I found it pretty easy to get started with. So it's a really, really cool tool. So let me switch back over here to our slides. And we'll do some wrap up and then kind of go through your questions. So as I hope we have demonstrated at this point, Codefresh makes it very easy to continuously release and also roll back deployments of your services. And when you combine that with Lightstep and the ability to analyze your deployments, understand the health of your deployments as you're rolling them out, that's the best place for you to understand your service health and know when you need to roll back or when you know that everything's fine and you can keep on going and give you the confidence that everything is a-okay.
By the way, Austin, you mentioned Canary before. So with Codefresh, we have a marketplace of steps, built-in steps. We talked about some of them. We also have a built-in Canary deployment step, as well as a blue-green deploy step. And these steps, as well as like all of the other steps, are designed as self-contained functions. So it's completely declarative. You just, for the Canary deployment step, for example, you can just define the percentage of the traffic that you want to migrate to the new version. It has a built-in health check and all that. So for those of you who are interested in Canary deployments, you can check it out.
Yeah. So with all that said, I want to leave plenty of time for questions because I saw we were getting a lot of them. So let's do that and kind of take
Yes, thank you so much, Austin and Guy. We do have several questions in the Q&A, and then we have a couple questions in the chat as well. And I want to make sure to not glaze over this one because it went into answered. Christian was just asking if Lightstep rebranded. He thinks he met you at KubeCon 2018, but the brand seems a little different. And I said, you guys did change your logo recently, but maybe you could elaborate a little bit on that, Austin.
Yes, we just launched a new brand at the beginning of this month into last month. The original plan was actually to introduce that at KubeCon EU, but the current state of the world made that not happen. So, but yeah, same company. one of the big things we offer now that maybe we didn't before, we now offer free host infrastructure metrics. So check out lightstep.com. You can also go to the link you see on this slide, go.lightstep.com/trial to start a free 30-day trial, or sorry, 14-day trial of Lightstep and kind of play around with our new features. Just for this demo, like I didn't get into a lot of the metric stuff because it wasn't necessarily interesting for what we were doing, but that stuff is there now. So
awesome. And I just want to remind everyone before we continue with the questions, we are going to be doing a giveaway just in a few minutes after we're done with questions for a Nintendo Switch. So please stick around just for a few more minutes after the questions. We will give that away live only to our attendees here. And I also want to launch some polls here while we answer the questions. So thank you so much for your feedback on these polls. We really appreciate it. It helps make our webinars better. And we will continue with questions. So it looks like Mustafa was asking, what is the difference between Jaeger and Lightstep? Is that one of your competitors?
yeah, I can take that. So that's a great question. Fundamentally, Jaeger is a distributed trace analysis tool. Lightstep builds on distributed tracing, adds in things like metrics to give you a observability platform. So what that means sort of on a day-to-day basis is Jaeger makes it really easy to go in and look at a trace, right, and to see like what happened. Lightstep gives you a lot more powerful analytical features built on top of that trace data. So if you're using Jaeger today, you can start to point your Jaeger data to Lightstep and immediately take advantage of things I showed, like root cause analysis features, automated deployment detection, analyzing kind of errors and other things that happen, and automatic correlation detection, like we kind of showed in the Explorer there a little bit. So we're using the same sort of data, the same type of data, but enhancing it with a lot more features that open source tools don't necessarily give you.
Awesome, thanks. And then Christian asked, are you, and I think this has to do just with the end of the demo, are you able to compare two different timelines, such as today versus the same day last week?
Yes, you can either do sort of specific comparisons, or for all your data, we're able to, for 100% of the data you're bringing in, we create aggregates off of those, so you can actually compare the histograms between like a day ago, a week ago, a month, a day ago, a week ago, an hour ago, or custom, and see like what did this, for this given query, right, for this service with these tags, what does that look like over time. And you can also do that in the stream view, and in when we were looking at that investigation view, the detector regression or whatever, you can give that custom times as well. So you can say, for this hour or these 10 minutes of time between these 2 days, show me everything that was different and show me everything that was similar. And then we'll surface kind of the things that have the most difference, and also let you compare, like, for customer foo, it took, this was on average 100 milliseconds slower compared to this time last week, right? If you'd like to know more, I would highly encourage, if you want to know more about like the Lightstep stuff, I would highly encourage you to go to our website. There's a sandbox on there you can play around with. You can also get like a demo where someone that is better at giving demos about our product than I am to give you the demo.
Sounds good. And we have a question for Guy. Can we integrate Codefresh with tools like Datadog?
Yeah, so we're actually working on, this is one of the next features to come, of integrations with tools like Datadog to get, to get like a built-in monitoring integration. I have some custom script step that I created for Datadog, so you can ping me after and I can show you how I did that. I also see another question there from Tim, I think, how does automated CI/CD compare with, say, Ansible? So Ansible, you can use Ansible for the deployments, right? But Codefresh is kind of like a bigger scope. So it's a CI and CD platform. So we can create the workflows all the way from like Git triggers and built-in steps for like cloning the repo, building Docker images, running unit tests, integration tests, all that stuff, as well as the deployments. And there's some advantages of using one platform for both the CI and CD. Like, for example, we saw like the images view where you can trace back the changes all the way from your deployments back to the code change and all that stuff, as well as it's a service, so you don't have to kind of like build everything yourself and maintain it and all that stuff.
There's a question in the chat a little while ago from John. Does the software have log aggregation capabilities? So you are able to send log data to us if it's attached to a span, and without saying a lot, like, we're working on interesting ways to integrate that with the overall experience. So, keep an eye out. There's also a question in the chat from Tim. How does this fit with OpenShift and AWS? The vendors are providing value-add monitoring on top of Kubernetes. So yeah, Lightfresh is I'm sorry, that's like the 5th time I've accidentally said Lightfresh. Lightstep is completely agnostic to where you've deployed your software. You can run on Kubernetes, you can be running on bare metal. The metrics and the trace data that we're getting are from your application, from your service. So there are a lot of ways to do this that's a little easier. Like if you are using Kubernetes or OpenShift or whatever, and you're using like a service mesh, so like Istio or something, then that can generate the trace data for you and send it to Lightstep. If you're using Envoy as sort of a ingress proxy, then that can generate trace data about container to container communication and send it to Lightstep, or service to service communication and send it to Lightstep. There's a lot of ways to implement this that are kind of beyond the limits of our webinar to talk about. But again, I would encourage you to check out lightstep.com. Our documentation has a lot of learning paths and examples on how to do some of this stuff.
Looks like we have one question in the Q&A for Guy. Are there any examples out there for deploying Kubernetes test clusters like Kindi? That's the only thing we still use VMs and CI for, and we'd love to get rid of those.
Sorry, I was muted there. So yeah, definitely. I have some examples for that, and you can ping me after, John, or I can, yeah, just send you some examples after the webinar. No worries.
And just confirming for Prasanth that yes, the recording will be shared. So everyone look out for this recording by tomorrow, and it will be sent right from me, Taryn, at Codefresh. So look out in your inbox tomorrow for the recording if you missed any of the presentation. And I just want to make sure that we got to all of the questions that are hidden in the chat here. Sorry, did we get the one from Tim about how does this fit in with OpenShift and AWS?
Yeah, I just answered that.
Okay,
I see
I'm sorry.
Another one from Penguai.
Typing another chat.
Oh, you're good.
But looks like we have just about, oh yes, there's one more. Does adding telemetry increase latency of app, more dependency?
So yes and no. Like any kind of, so just on a simple level, right? Like you're adding more operational complexity to the application. So yes, there is some overhead. However, usually that overhead is pretty low. I think just in terms of what I've seen, you're anywhere from like a 1 to 2% resource consumption, like memory CPU cycle over kind of baseline. Because up to, I don't know, like maybe the worst case I've seen is maybe like 10%, right? Now, that's highly dependent on a lot of factors. One, that's dependent on how much instrumentation, how much telemetry you have coming out of the application. That's dependent on the language you're running in. Certain language, like a Python app is going to be a little less resource efficient, I would say, than a Go application. For the most part, in general, a lot of the overhead is sort of front-loaded though. So depending on the application, depending on how you've instrumented it as well, right? If you're using like an agent or something that is hooking into the process at runtime, then there's usually more it's usually more front loaded, right? Where the application initializes and then the agent has to go in and hook into all of your different method calls, right? If it's sort of just inline code and you've instrumented directly, then that is kind of amortized over the lifetime of the application, aside from the initial creation of a tracer object and a couple of other things. However, trace data by itself is pretty efficient. It is communicated, a couple of different reasons. One is it's generally communicated through like a protobuf or some sort of compact binary format. So the actual sending it off somewhere is pretty straightforward. It's done very quickly, very rapidly. So, I think I like to say maybe 2,000 spans a second or something out of your process into another aggregation process. And for the most part, it's not quite streaming, but think of it as a stream, right? You're sending everything off to this other process for aggregation and indexing, so it's not happening in your application itself. Your application code is just creating an object, serializing it, sending it over somewhere else, and then it's done. And that all happens on a different thread, so it's not blocking. Excuse me, so it's not blocking anything. However, your mileage may vary. This all can get a little hinky in production. It's something that does take a little bit of like, not trial and error, but like you roll it out in 10% of your services, see what it does, and then go from there. However, the thing that makes the trade-off worth it is that the value you get out of that telemetry data and the value you get out of tools like Lightstep really overwhelms like the additional resource consumption of your container or of your application service, right? It's not making the service slower, it's making the service use more resources, but the time you save in investigating an incident or trying to actually validate a deployment far makes up for that resource overhead.
Awesome. Looks like, yeah, a couple more questions in the chat here. And then just in 2 more minutes, though, I want to give away that Nintendo Switch and we can head back to the questions. But let's go ahead and answer Jim's question.
Yeah, Jim, I would probably email me about that, austin@lightstep.com. There's some things that we can try.
Sounds good. So then Jim, if you'll email Austin, and then we have some time, we'll just answer John's last question here and go to the Nintendo Switch giveaway. How easy is it to plug into GitLab?
GitHub. I think. Yeah, I think it says, and I'm assuming John is referring to Codefresh or the Lightstep. Yeah, probably Codefresh. Austin, maybe you can quickly show. Quickly show Codefresh again. Yeah, just the account settings, the integration section there. We already showed how you can easily connect to any Kubernetes cluster or Docker registry. There's also a Git integration section there where you can just, we have built-in integrations both with GitHub, GitLab, Bitbucket, Stash, Azure DevOps. Recently added support for Google Cloud Source repositories as well. So if you can click on Add Git Provider there, Austin, and you'll see all of these providers are out of the box. And we support both the GitHub Enterprise as well as the Cloud SaaS version. So even if you have like an on-premise instance of GitHub and it's behind firewall, you can also easily integrate it.
I will say I set up the GitHub integration for this, and it was super easy. It's like one click.
Awesome. So with that, thank you everyone for your great questions, and we will move on to our giveaway. So I have 35 attendees and I'm randomly generating a number for my list here, and looks like my winner is Christian Little. So Christian, congratulations. You are the winner of the Nintendo Switch. I will reach out to you and so we can get your address information and send that over to you. So thank you again to Guy and to Austin. Greatly appreciate you putting together this awesome webinar, and thank you all for your great questions and your poll responses. And we hope to see you next time on Codefresh Live. We have 2 great webinars coming up next week, one on Helm 3, and then another one with root level technology talking about Helm files. So check those out on codefresh.io/events, and we will see you soon. Have a great day, everybody.
Thanks, y'all.
Thanks, Darren. Bye, guys.
Bye-bye.
Bye.